Hey guys, Dr. Stitzel here. So we've put together the ideas of supply and demand to make a market, to get equilibrium, and then to think about what prices do and how they allocate resources according to the information that's signaled by prices. What we want to do now is talk about another idea called elasticity and show how it helps us understand the way that markets behave, and we can use it as an analytical tool. In this course, we're going to focus on what's called own price elasticity. There's actually lots of different varieties of elasticity. For principles class, we'll mostly focus, especially in this video, on own price, that is the price of the good in question. So you can have cross price elasticity, so the sensitivity of goods that are consumed in substitute for each other or in conjunction with each other, how they would respond to each other's price. That's called cross-price elasticity, but here we're talking about own price elasticity. So if we're thinking about the elasticity of demand for oil, I'm meaning in this case the own price elasticity of demand for oil. So how does oil respond to changes in its own price? We're going to talk both about the elasticity of demand and about the elasticity of supply. So elasticity of demand measures how responsive the quantity demanded is to a price change. More responsive then is more elastic. Similarly, elasticity of supply measures how responsive the quantity supplied is to a price change. More responsive, again, is more elastic. In this case, the important lesson here is that elasticity is about the sensitivity to price. So the more sensitive, the more elastic we are. So we're measuring the relationship between price and quantity, just like we were with supply and demand. Now we're thinking about what that relationship is in terms of how people respond to price. Okay, so let's start by visualizing. Okay, so suppose we have a demand curve, and we want to think about how sensitive are we to price. The way to begin that is begin by visualizing the response to a change. So in this case, we'll take a price change and we end up with something that looks like this. This is a demand curve that is roughly unit elastic, sort of a one-to-one relationship. You can see the change in price is roughly the same size-wise as the change in quantity. That's what we call unit elastic. Imagine that we have a demand curve that's somewhat flatter. In this case, we look at a pretty small price change. You can see that a small increase in price leads to a quite dramatic increase in quantity. So price lowers a little bit, then we see a very large increase in the amount that is demanded, the quantity demanded. So this is an elastic demand curve. One is more vertical, as I'll show you when we get to supply, but demand curves can be inelastic or elastic. Supply curves can be inelastic or elastic. Here I'm just highlighting sort of how to visualize the elasticity of demand, showing an elastic, this is what we call unit elastic up here, demand curve. Okay, so in the same way that we're interested in supply and demand, the things that determine the relationship between price and quantity, we're also interested in the things that determine how elastic, how sensitive to price something is. The most important one is the availability of substitutes. Now, there are two factors here. One is the number of substitutes, and the other is the quality of substitutes. Okay, so how sensitive I am to the price is determined by how easily I can move away from that good. So we're talking about determinants of elasticity. In this case, we mean demand elasticity. So if I have something for which it is very easy, I have very many types of substitutes, then we'll be very elastic, we'll be very sensitive to the price. Good example of this would be your options for going out to eat. So if you're going to go out to eat tonight for dinner, you have a wide range of options, right? You could go to a fast food joint, you could go to McDonald's, you could go to Burger King, you could go to a nice upscale restaurant, right? You can go to the steakhouse, you can go to an Italian restaurant, and everywhere in between, right? You even could consider other types of substitutes. Eating at home is a substitute for eating out. There's a wide variety of things available to you. So that's a high number of substitutes, right? So a high number of substitutes increases in this, or high number of them, will make you more elastic, more sensitive. The other thing to think about is the quality of the substitutes, right? So you can have a wide number of them, but then be kind of poor substitutes. So we would think the elasticity of demand for a product like Coca-Cola might be very high, might be very elastic. And the reason we would think that is there's a wide number of substitutes, right? You'd have Pepsi would be an obvious close one. For many people, Dr. Pepper is a good substitute for Coca-Cola. We can think about root beer. We can think about other types of drinks, right? We can think about water, coffee. There's lots of things that we can use to satisfy our thirst. There's a high number. We could also argue there's probably a high quality. For most people, they're not super picky between Coke and Pepsi. If I'm at a restaurant and the waiter or waitress says, what would you like to drink? And I'll say I have a Coke. They say, well, we only have Pepsi. I might say something sort of tongue-in-cheek, but I might say something like even better, right? I'm more or less indifferent between those things. So a very high quality or an increase in the quality will make you more elastic. Now, the number of substitutes is also very sensitive to the time frame that we're talking about. Consider your elasticity of demand for gasoline. If your car is running low on gas and you need to get to work, you need to get to school, you need to go out to dinner tonight, whatever it is that you're doing, if you go to the gas station and the price is quite a bit higher, what kind of time frame are you looking at? You could maybe delay another day depending, how badly you need the car, how low your tank, how badly you need to use the car, how low your tank of gas is, right? So the longer the time frame, the more elastic we'll be looking at. So what happens if we think about your sensitivity to the price of gasoline over a very long period of time, right? You can get a more gas-efficient car. You can use the bicycle more often. You can move towards using public transit. You can do many things over the long term that aren't really very viable in the short term. Another type of determinant for elasticity is the product category. And what I mean by this is sort of, are we talking about a product in general, or are we talking about a brand, right? So brands will, if we're talking about a brand, the elasticity for a particular brand will almost always be more elastic. And the reason for that is, if you're saying, what's your own price demand elasticity for Coke? Well, all those other brands, Pepsi's, count as substitutes in that case, so you'll be more elastic in that case. If we're talking more generally, we're talking about carbonated drinks or something. That's a much more broad category, much more general than brands are. You'll actually be somewhat less elastic in that case, right? Because the substitutes are fewer and they are poorer in quality, right? So the nearness of the substitute between Coke and Pepsi is much closer than the nearness of the substitute between Coke and water or Coke and coffee or something, right? And so the more you broaden that, what if we broaden it even further? We generalize even more. What about drinks in general? Well, our elasticity for that will be even lower than for carbonated beverages, right? Because you end up needing to be able to drink water or whatever it is that's going to sustain you. Now, in a particular moment, you still might forego that, right? If you went to the restaurant and they said, you can get the steak for $10, but the soda that goes with it is $25. You say, okay, well, I'll just have water. And they say, well, actually, water is $30. You still might be able to eat the steak and not need the drink in general. But your sensitivity to that price is much, much less, because at the end of the day, you have to have fluids to drink, right? So you can you can see that the more broad, the more general we make the category, right? Food and drink, just drink. Carbonated beverages, a particular brand of a carbonated beverage, maybe a particular flavor of a particular brand, right? So the most elastic we would be when we're considering this determinant might be we are considering the vanilla Coke, right? And so there's lots of substitutes for that, even within the brand of Coke, regular Coke, Diet Coke, Cherry Coke, all these options that might substitute for vanilla Coke. Okay, that brings us to another one, which is necessities, right? Some goods it's hard to be sensitive to the price for because you need them very, very badly. Other things you can be less sensitive to because they're not really necessities, right? So your television isn't likely to be a necessity, so your sensitivity to the price of the television will be much, much higher, right? If we're talking about a dessert or a snack as opposed to a meal that you're eating for sustenance, necessities are going to make you less sensitive. Okay, so the more necessary makes us less sensitive to price. More necessary, less elastic. So less sensitive to price. Okay, the final thing is sort of the ratio of the price to your budget or to your income. Right, so a really big percentage change in price for an item that is very low in price, right? So a 50% increase in a stick of gum that costs $1, so it goes up to $1.50, isn't going to change our total consumption very much because it's a very small portion of our budget. A 1% change in a price or of a house or a car will cause us to be much, much more sensitive. So the larger portion of the budget here the more elastic, the more sensitive. More elastic. Okay, so there are many ways to calculate elasticity. In this class, we're going to just focus on the midpoint formula. So the equation is written out here. It's the percentage change in quantity over the percentage change in price. That's the same way to say how sensitive to price is quantity. So put another way, the change in quantity, right? That's the change in quantity, expressed as a percentage, so percentage from the base, over the change in price as a percentage to the price. So let's take an example and do a little calculation here. In fact, we can sort of do these in two parts if we'd like. So I'm going to take these numbers here and use them as an example. So we take the second quantity. So there's an increase in price here, so we're going to see a decrease in quantity. That's our expectation when it comes to elasticity of demand. So we go down to 20 units purchased, and we are doing that from 100 units being purchased. That's over the initial 100, right? So we can see that it's a decrease of 80 expressed as a percentage. That's pretty clearly going to be 80%. So we'll write it first as a decimal and then as 80% decrease, right? So we see an 80% decrease in the quantity demanded. Okay. We can also take the second part here and we can express this as a change. So the price went up. We now have a price of. We now have a price of 50. We had a price of 40, so we're seeing a change here as well. Pretty straightforward. Oh, sorry, that's a positive there. 0.25 or a 25% increase. Okay, so when we put it that way, we can see, fairly clearly in this case that we have a situation where our percentage decrease in quantity is larger than our percentage change in price. So the reaction in quantity is larger than the change in price. So percentage change in quantity larger than the percentage change in price. Of course, we can work this out. The way that we've expressed this here doesn't make it super convenient, so we'd actually would want to go back a step to where we actually have the fraction. So bear with me for a moment, right? Where we have 8 over 10, and that would be 1 over 4. So we'd invert and multiply. So we can see something like that. The important lesson here, as you can see where I'm going with this, is that this number ends up greater than 1. So we have several lessons here. So if your absolute value, remember, because this number is going to be negative, right? Going back there, bear with me. If the absolute value of this thing is greater than 1, that's what we call elastic. So the percentage response in quantity is greater than the change in price. If it's less than 1, it's what we call inelastic. If it's equal to 1, it's what we call unit elastic. So a 1-to-1 response. Okay. So one thing that helps us when we're thinking about elasticity of demand is that it's related to total revenue. So total revenue, of course, is the price of the things that you sell times the quantity that you sell of them. Fairly straightforward. Our accounting and finance comes in handy here. So what this teaches us, though, is that if the elasticity is very high, so remember we said this is elastic here. So if we're in an elastic situation, right, the change in price will also be matched with a much larger change in quantity. I should be careful here because this is actually a decrease, right, because we're talking about demand. A much larger change in quantity. So in an elastic situation, we're actually going to see total revenue tends to fall if we raise the price because the quantity response is larger than the price response. If we're in an inelastic situation, then a very large change in price leads to a very small change. It's insensitive in this case. Raising the price will actually cause our total revenue to go up. And of course, as you might imagine, in the unit elastic situation, the changes are equal, right? And so you'll see no change in total revenue. No change in total revenue. Now, one of the things that we won't make too much of in a principles class is that when you're moving along a demand curve, you actually have different types of elasticity all along the curve. We won't make too much noise out of that except to say that helps us make sense of having a single demand curve. In this case, we can actually find the place that optimizes revenue for a firm. We'll talk about firm behavior a bunch later in the class. But for now, we can just have a sense of what happens to total revenue if the price is raised in an elastic situation versus if it's raised in an inelastic situation. Notice that doing the reverse here would also lead to the opposite, right? So in an elastic situation, a decrease in price will cause there to be so many units sold that it will actually raise total revenue. Okay, let's take an example of this. And one of the things, especially if we're here in this part of the country in West Texas, one of the things we think about a lot might be farming and the history of farming. So let's take the market for farm-produced food. Of course, demand for farming products, for food, it's necessity, these days especially, relatively small part of the budget, very poor substitutes for sort of food broadly in general, right? We would expect that the demand for foodstuffs is very inelastic. We're not super sensitive to the price of food because we need it, right? And so simultaneously, what has happened in the market on the supply side is that there's been large increases in technology and the efficiency of production, which of course causes there to be an increase in supply. Remember that that's a rightward shift. So supply one, supply two. So what has happened in this situation where we have highly inelastic demand? Well, we started the relatively high price associated with the quantity. Over time, of course, we know that there is a decrease in price associated with increasing supply and an increase in quantity. But since the demand for farming products is very inelastic, what that means is that this change in supply has caused a very large decrease in price associated with only a very small increase in quantity. So in other markets where we would have very elastic demand, an increase in supply would lower the price a little bit, but be connected with a very large increase in quantity, right? We just learned that here from this previous page. So what's the consequence for farming? Well, the price that farmers get is quite a bit lower, and the amount that they sell is only a little bit bigger. Let's highlight this total revenue. Remember our total revenue equation. Total revenue is price times quantity. We actually have both of those things here on the graph, so we can see that it's going to be the rectangle coinciding with the price and the quantity that are made available. So let's look. Our initial situation, right, is a revenue that looks something like that because it's this price 1 times this quantity 1. Now, quantity is increased a little bit, but in the second scenario, revenue looks like that. Just by visual inspection, we can see pretty clearly that the revenue that we've made the blue rectangle here is quite a bit larger than the rectangle from the pink rectangle. So we can see that total revenue has actually dramatically fallen as a response to the increase in the technology in farming. So the lesson here might be you want to be in an industry that's going to have very elastic demand, which is if you're going to have increases in supply. I guess the reverse would be true if you're going to have dramatic decreases in supply over time. So think carefully about the trend of the industry. Let's take another example of elasticity of demand. Is going to come to us from the war on drugs. So drugs are another good example of highly inelastic demand. And the reason for that is because drugs are addictive, so that causes users to be very insensitive to the price, to the point that they will often obviously make very bad individual choices related to that. Okay, let's take a quick example before we have any war on drugs. We have this supply curve, okay, supply 1. What is the intention of the war on drugs? Well, the intention on the war on drugs is to reduce supply. I want to show that in this case I'm saying supply is very elastic, very sensitive to price. I think that's a good assumption, right? Because you have, we'll talk about the determinants of elasticity of supply here in a minute, but there isn't a lot of good reasons to think that the suppliers of drugs have much in mind other than the price, right? So they're very, very sensitive to price. Well, what happens is you want to decrease supply. In this case, the war on drugs, right, does that through legislation and penalties, policing, etc., which will mean it will raise the price at which suppliers have to be compensated in order to supply the same amount. So that will look like the supply curve going up. So remember all the way back at the beginning of this course pointing out that supply is sort of backwards because we have price and quantity here. So this is actually a decrease in supply despite the fact that it looks like it's going up. Just remember that in order to produce the same quantity, suppliers would have to have a much higher price. So that's how we would view this. All right, so we've got price 2, right? And we have quantity 2. Quantity 2, okay? So here's the war on drug effects, right? And it dramatically reduces supply. The problem is, because demand is inelastic, a reduction in supply leads to a very small change in quantity in conjunction with a very large increase in price. Again, let's take a look at the revenues that are going to be involved here, right? Initially, we had this blue line, right, where you have very low price and a somewhat higher quantity. And yes, the war on drug works in some senses because it reduces the amount of quantity that's on the market, but it does so by dramatically raising the price. So you can see by visual inspection, total revenue is actually going up, because while the price is rising, the quantity, in this case because it's inelastic, is going down very little. So it's actually more profitable to deal in drugs in this situation. Okay, so a couple examples there of how to use elasticity to study policy or various trends in the economy. Okay, now let's talk about elasticity of supply. I think I promised you that I would show you inelastic supply, so let's do that. We've already kind of seen some examples, so you have a sneak preview from the previous couple of slides. Now remember, supply can be elastic or it could be inelastic. So now suppose we have a very large change in price, but we're dealing with an inelastic supply curve, so we'll see a very large change in price lead to a very small change in quantity. Since we've already kind of done this before, I'll do the unit elastic case, very quickly. So if you have a change in price, and again, I'm mostly doing this to visually highlight the two different situations that I'm drawing here on this curve. You can see that in a unit elastic situation, you have a roughly equal size change between price and quantity. Okay, so the determinants of elasticity of supply begin with what I'll call marginal cost. We haven't really introduced that idea yet in class, but the reason that I want to call this marginal cost is because I want to make the point that the principal elasticity determinant for supply is if you increase production, will it change your per unit cost? Okay? So in a scenario where it doesn't increase the cost to produce more, then you will produce more. You'll be very sensitive to the price. If by producing more you raise your costs very quickly, then you will respond less to price. Price changes have to be bigger to induce you to produce more. Okay, so if it's easy to produce more, without raising cost, you're going to end up in a situation where you're more elastic, more sensitive to price. Right? So if it's difficult to produce more without raising cost, you'll be more inelastic, less elastic. Okay. Related to this is how large a share of the market for your inputs you make up. So if you're a really big producer who's using up a car producer, right, and we're using up a high proportion of the total market for rubber, say, then by producing more cars, the total demand in the market for rubber goes up. That's going to increase the price. So I can kind of, by increasing my production, I will increase my own input costs, right? Okay, so if we're a small share of input market, then we'll end up being more elastic. Right? So if by increasing the amount that I produce, I don't change the price much because I am a small producer, then I'll be more sensitive to the price. It's easier to induce me to produce more. Okay. Global supply chain versus local supply chain. So if it's sort of related to these other ideas, right? So if you have a case where, let's consider the supply for oil, right? If the supply of oil, it's going to be inelastic because world production, global production, won't increase much without a significant increase in the cost per barrel, right? But now imagine people move to Texas, right? They increase demand for oil by moving to Texas. It's much easier to ship oil to Texas from other parts of the country or for other parts of Texas than it is to ship oil to Texas from other places in the world, right? So local supply chains will be more sensitive to price than global supply chains will. And again, time frame works in the same way, right? So in a long time frame, let me note this really quickly, right? So local tends to be more elastic. A long time frame allows us to adjust more, so we'll be more sensitive to price. So in the same way that consumers are thinking about what are my options for substituting away, producers in a longer time frame can respond better to changes in price because they can increase or reduce production as the market dictates to them. Okay, so I don't want to do the calculation again. It's exactly the same as what we did before. We'll just end up with price increases leading to positive numbers. So if you still use those same heuristics, the absolute value of elasticity of supply leads to us to be able to analyze it. So in elasticity of supply, the numbers will be positive, so you don't technically need the absolute value. But if we always remember the absolute value of elasticity, leads us to how we would calculate whether it's elastic or inelastic. You'll never go wrong. So it's just always best to think of it that way. All right, so let's think of another kind of fun and controversial policy program, sort of the opposite, I guess, in some sense of the war on drugs, right, would be a gun buyback program. All right, so the first thing we have to talk about is the theory of gun buybacks is pretty straightforward, right? If you reduce the number of guns, then you'll reduce the amount of crime, right? So seems straightforward enough. Let's think about how that might work. So we're thinking about the market for guns. What's the supply of guns look like? Well, that depends on what type of guns are going to be bought in a gun buyback program. So I'll challenge you to a thought experiment first. So I want to introduce a shoe buyback program in here in Amarillo. Which kind of shoes are going to be sold to me in my shoe buyback program? Well, if you have an old pair of shoes and you have a new pair of shoes, and I come to you and I say, okay, City of Amarillo, no questions asked, just sell us your shoes. We want to buy back your shoes, get those shoes out of society. You're not going to reach for your brand new Nikes, right? You're going to reach for those old, worn out Adidas running shoes that you tucked under your bed 3 months ago to get away from the smell, right? So in that sense, it's pretty easy to think that in those scenarios, you're going to have a very, very elastic supply of guns, right? You're going to be very, very sensitive to the price, right? So we're going to have an elastic supply curve. So what happens to demand? Well, for these type of guns in particular, right? So we might think of older guns, lower quality guns, right? People aren't bringing their brand new top of the line multi-$1,000 gun to a gun buyback program, right? They're bringing grandpa's old 6-shooter that barely works. And in fact, some of these programs are no questions asked. So you'll actually buy a lot of guns in a gun buyback program that don't even function, right? So initially demand will be like this. By definition, you have to see demand increase in this scenario, right? That is what the gun buyback program is doing. is increasing the amount of guns that are being bought. What happens then in the general market, because demand 1 reflects demand without the buyback program, demand 2 reflects it with the buyback program. Well, you have some initial price and you have an initial quantity of guns. If supply is very elastic, then you're actually going to see an increase in the amount of guns. So our expectation will be the price for guns will stay the same. Now bear in mind I'm talking about lower quality guns, right? You might say, well, what if the supply curve included all guns, right? Well, then higher priced guns, the elasticity of those would probably be more inelastic, less elastic in that case, right? So the somewhat predictable outcome in this case will be that we would see more guns come to markets where they do gun buyback programs, those guns specifically being older and lower quality guns. Okay, so there we have it. Some exposition on elasticity, both supply and demand, how to calculate it, what are the determinants of each, and a couple of examples, and really a useful way to think about how we would analyze both policies and just sort of trends in the economy using elasticity.